Will wormhole travel ever be possible? What makes humans different from other species on this planet is that we are a curious species. As a curious species, humans have long dreamed of traveling deep into the future to see if we could travel time. This exactly has been portrayed in the epic science fiction movie Interstellar, in which Matthew McConaughey and Anne Hathaway traveled way back into the future. If you have seen this movie, then I'm sure you are asking one question in your mind. Is time travel really possible? The universe is outrageously big. However, along with its enormous size, it's also spread out almost evenly everywhere. Any neighboring planets, stars, and galaxies are depressingly distant. For example, the closest star to Earth is Proxima Centauri. Still, the distance between Earth and this star is 4.22 light-years away. Even if we send our Voyager spacecraft out to Proxima Centauri, then it would take around 80,000 years to get there. Now, 80,000 years is way into the future. So how are we supposed to explore the universe in a way that won't spend thousands of years? Amongst many concepts, researchers have devised one technique that has been very famous in the physics world, as well as in the science fiction world. It is the technique known as wormholes, or shortcuts, or theoretical tunnels. In theory, wormholes are tunnel-like pathways which bridge space and time, thus offering a shorter distance between two vastly separated areas of the universe. So, the concept is that space travelers can use these pathways or tunnels to make space commutes in much shorter time than thousands of years. There are numerous books, films, and TV shows that have utilized the wormhole concept for deep space travel. This plot was utilized exceptionally well in the movie Interstellar. In this film, few astronauts travel through a newly discovered wormhole connecting widely separated areas of space and time. They do this in order to find a habitable planet like Earth. This certainly sounds incredible, as if all our space travel fantasies can come true. But the big question is it possible? Could humans explore this technique for real, to travel to other distant galaxies and beyond? Science says it's highly unlikely, yet possible. To make such traversable wormholes, we need a lot of specific conditions and an understanding of where these amazing secret gateways come from. Newton's gravitational laws were held supreme up until the early 1900s. Newton's gravitational law stated that each and everybody in the universe attracts each other with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. So, we have an innate force within us which attracts other objects. However, the larger an object, the greater this intrinsic gravitational pull. This is a fundamental law about gravitation, and it explains why we are glued to planet Earth instead of flying off into space. Later, in 1915, Albert Einstein completely shattered and rubbished that idea. He theorized that there is warping in space and time, and this causes gravity. Interestingly, an object's very existence twists space and time around itself, creating a depression in the space-time fabric, a combination of space and time into one continuum. These deformations in space-time give rise to gravity's effects. Let's see how this is connected to wormholes. As per Einstein and his colleague Nathan Rawson, a wormhole is actually deformed space that is warped in such a way as to connect two different points in space-time. Interestingly, the result is a tunnel-like structure that could be curved or straight. So there is a linking between two areas of the universes that are incredibly far away from each other. Einsteinian mathematical models predict that wormholes exist, but till date, nothing has ever been found. An astrophysicist named Fumio Abe from Nagoya University developed a technique to find large wormholes so big that a spacecraft can travel through it by looking at a star's brightness when it moves in front of the tunnel. This technique is called gravitational lensing, where the star's brightness gets fluctuated in a unique way. However, the chances of finding such wormholes anytime soon are slim. Currently, physicists haven't found a way in which wormholes would form naturally in the universe. Physicist John Wheeler said it's possible that wormholes may spontaneously appear and disappear based on his quantum foam hypothesis, an idea where the virtual particles are, quite weirdly, popping in and out of existence at all times. Unfortunately, as per Wheeler, these popping wormholes would be super small, appearing at the Planck scale. So, these wormholes would be so small that it would almost be impossible to detect them. Let's suppose that we could find such tiny wormholes as they pop into existence. Let's also assume that we could make them bigger. To do that, we would need a crazy material called exotic matter. Ordinary matter has positive energy density and positive pressure, whereas hypothesized exotic matter is different in the sense that it has a negative energy density and a negative pressure. You can have a cluster of matter with negative energy and positive pressure, or vice versa. Negative properties of such exotic matter may push the sides of a wormhole outwards, making it large enough and stable enough for a person or a spaceship to fit through it. Note that exotic matter isn't as easy to come across. It exists only in theory, so we don't know what it looks like, and we have yet to know where to find it. Let's assume we have found a tiny wormhole. We somehow obtained some exotic matter, and thereafter, we have expanded and stabilized the tunnel to be big enough to fit a spaceship. The problem then is that if we insert non-exotic matter through this tunnel, it would instantaneously destabilize the wormhole completely. This would mean that entering such a wormhole would immediately lead to death. Wormholes could very well connect two completely different spacetimes, though the entry point might exist in a completely different era altogether. Therefore, it's true to say that passing via wormhole comes with the risk of winding up at a different time in the history of the universe. Physicists who believe in the existence of a multi-universe or multiverse suggest that, in theory, wormholes could connect completely different universes altogether. If you've liked Inkstall's edutainment, then go to inkstall.in and sign up for free. Producing our videos takes a lot of time. If you'd like to support Inkstall, you can do so on patreon.com/Inkstall. Please refer the link below to buy Inkstall's book on space, time, and beyond.